Chapter 2, Lesson 5 is on solving absolute value equations or equations involving absolute value. And the first thing we want to talk about is what is absolute value? We need to really have an understanding of what absolute value is before we can solve the equations using absolute value. So let's go and define absolute value. Absolute value is distance from 0 on the number line. And distance is always positive. So absolute value is also always positive. It's symbolized with two straight up and down bars. The absolute value of 2 is 2. The absolute value of negative 2 is also 2. Anything coming out of the absolute value ends up being positive. So if I add two numbers together, I add them together first, it's a grouping symbol, and then I take the absolute value of it. If I get a negative, when I take the absolute value of it, it's positive. Absolute value is always positive. The only time I'll get a negative is if the negative is actually already outside. And that's because it just carries over. Nothing happens to it. Now, we cannot distribute into absolute value. So let's say, when we had our parentheses like this, we could distribute in. That's because we have a nice curve here we can slip around, and that gives me 2x plus 4. Lovely, we can do that. With absolute value, it's a wall. If I try to distribute in, I just bounce off. I cannot distribute in. Okay, so no distributing. It's a wall. And the reason that I mention that is because we will see things like the negative absolute value of negative 2. The absolute value of 2 is 2, and the negative hangs out. So this is negative. This is not the same as negative 2 here, where the double negative with the parentheses makes the positive. Okay, so we need to keep these things very separate. The first thing that we're going to do is we're going to evaluate expressions using absolute value. And so I'm going to evaluate m plus 6 minus 14, and that's the absolute value of m plus 6 minus 14 if m equals 4. Now this is very similar. I'm going to take the 4 and I'm going to plug it in for m. So I get the absolute value of 4 plus 6 minus 14. And then 4 plus 6 is 10. So I have the absolute value of 10 minus 14. The absolute value of 10 is 10. Minus 14 gives me negative 4. Let's try another one. 23 minus the absolute value of 3 minus 4x if x equals 2. So I'm going to take the 2 and I'm going to plug it in for x. So I have 23 minus the absolute value of 3 minus 4 times 2. 4 times 2 is 8. So 23 minus the absolute value of negative 5. The absolute value of negative 5 is positive 5, so I get 23 minus 5, and 23 minus 5 is 18. Okay, so that's how we evaluate absolute value expressions. We're also going to need to solve absolute value equations. And to do that, I'm going to actually start a little bit further back than the book starts. The book starts right into equations with other things happening inside the absolute value, and I want to kind of work our way up to it. So if I have the absolute value of x equals 5, remember that the absolute value of 5 equals 5, and the absolute value of negative 5 also equals 5. I don't know which one this is. So I get two answers. Whenever I have absolute value, I will get two answers, no answers, or if it's 0, just one answer, because 0 is neither positive nor negative. But in every other scenario, I should get two answers. So if the absolute value of x is 5, x is equal to 5 or negative 5. I don't know which one, so I write them both down. If I have some multiplication happening, I have to clear the multiplication first before I split and decide what the absolute value of x is. The absolute value of x is 8, so that means x is 8 or negative 8, because I don't know which one is in here. Likewise, if I'm adding or subtracting, I have to get rid of that addition and subtraction first. Oh, sorry, plus 6, plus 6. I need to get the absolute value completely alone before I do anything to it. So absolute value completely alone is equal to 10. That means that x is equal to 10 and negative 10. Now, sometimes when the x is not alone, we have a different scenario. So let's look at if we have the absolute value of 2x equals 8. Well, that means that 2x equals 8 or 2x equals negative 8. I have to split and then solve. Divide by 2. So I get x equals 4 or x equals negative 4. Now in this scenario, I got the same number twice because I was just multiplying. But if I have an example like the first one in the book, where I'm adding, the absolute value of f plus 5 is 17, I have to split and solve. So I get f plus 5 is equal to 17, or f plus 5 is equal to negative 17, because I don't know which one it is, because the absolute value of 17 is 17, and the absolute value of negative 17 is also 17, so I have to account for both and solve them separately. So I get an answer of f equals 12, or subtracting 5 on this side, I get that f equals negative 22. I'm always going to get, like I said, two answers. Sometimes I get the positive and the negative of the same number. Sometimes I get completely different numbers, and that just depends on what's happening inside the absolute value. So let's look at another scenario, another example from the book. B minus 1, absolute value, is equal to negative 3. Absolute value is always positive. This is negative, so there's no solution. But we can only jump to that conclusion if we have the absolute value completely alone. Here's a scenario where you might think, oh, that's a negative, but we're multiplying by negative over here. So I need to get the absolute value completely alone first. So I have x minus 5, absolute value is equal to 10, positive 10. That is okay. Then I split and solve. x minus 5 equals 10, x minus 5 equals negative 10. Add 5 to both sides. X equals 15. Add 5 to both sides. X equals negative 5. So x equals 15 or negative 5. We do get into more complicated scenarios with the absolute value. Doesn't look like we do so much in this section of the book, but just to go over them just to be safe, you want to isolate the absolute value first. So that means we need to do any addition or subtraction or multiplication or division to get this alone before we split. Then, if we have the absolute value alone equals a positive number, we split and solve. If we get the absolute value alone equals a negative number, we have no solutions. We cannot have a negative absolute value. All right, let's look at solving an absolute value equation given a word problem, and these ones always kind of struck me as a little silly. Don't tell anybody I said that. The temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit, give or take 5 degrees Fahrenheit. Find the maximum and minimum temperatures. Okay, here's what they want you to do. They want you to set up a number line and use the absolute value to travel 5 units each direction and solve the equation that way, or they want you to actually write an absolute value equation, and that would be the temperature minus 80 degrees is equal to 5, because 5 is our difference, and then solve it, which we can do. That's x minus 80 equals 5, x minus 80 equals negative 5, and I get x equals 85 and x equals 75. But a much easier thing to do is to take 80, add 5, take 80 and subtract 5. This is my max, and this is my min. So let's do one more example, and I'll show you the correct way and then the easy way. We have ice cream. I can't write. Ice cream should be stored at 5 degrees with an allowance for 5 degrees. We want to write and solve an equation. So our temperature minus our 5 degree allowance should be our ideal temperature of 5 degrees. So x minus 5 equals 5, or x minus 5 equals negative 5, giving me x equals 10 or x equals 0. Again, the easy way, I take 5 and I subtract 5 and I add 5 to get a 10 max and a 0 min. Okay, and that is how we write and solve absolute value equations. And now we will go on to the note taking. There's really not an algebra tile use with absolute values, so I can't show you how to do that.
Here's the note taking for section 5 on chapter 2, and you want to write 2 facts you learned, but I'm going to go ahead and write down what we're supposed to learn. Evaluate absolute value expressions, and then also solve absolute value equations. Okay. We have our vocabulary. The term 5y represents we have algebraic expression, product, power, and variables. So we're going to go with product. Arrow A is pointing to an algebraic expression. Arrow B is pointing to a power, also known as an exponent. And then arrow C is pointing to the variable y. Defining absolute value in our own words, absolute value is distance from 0, and it is always positive. We can't have negative distance. So we're going to evaluate the following absolute value expression if f is negative 9. So I'm going to plug in negative 9 for f. That's 11. Negative 9 plus 7 is negative 2. Absolute value is always positive. So that's going to give me 2 minus 11. And 2 minus 11 is negative 9. So the value of this expression, if f is negative 9, is also negative 9. Okay, we have 3 types of open sentences involving absolute value. An absolute value of n is less than 0. Okay, there are no solutions here. Absolute value is always positive, so it cannot be less than 0. If absolute value of n equals 0, then n equals 0. It's the only thing it can be. And if absolute value of n is greater than 0, well, that's all real numbers. N is not equal to 0 because we want it to be greater than 0. So it's everything other than 0. Alright, we have an absolute value equation. We want it to fit the solution. So we want some absolute value to be 3 units away. So they give us a sample one. We can write anything we want. I can just say the absolute value of x plus 2 is equal to 3. And that would mean, I'm going to move over to the side here, that x plus 2 equals 3 and x plus 2 equals negative 3. So I subtract 2 from both sides. I get x equals 1 and x equals negative 5. So my solution set is 1 and negative 5. And what is one way we could check to see that my graph of an absolute value equation is correct? Well, if I want to check to see if my graph of an absolute value equation is correct, I can plug in my solutions from the graph to see if it makes a true statement. That's just one way. You might have come up with another way, and as long as your way is valid, then everything's good. And that's the end of chapter 2, lesson 5.